Alright, hi you guys, welcome to AP Calculus AB, and we'll be talking about inverse functions today. Okay, so first off, inverse functions, if you remember, whenever you find the inverse of a function, in order for the inverse to also be a function, it has to be a one-to-one type of function, so you have to be careful about that. But also, you need to know that you're switching the domain and range. So the domain and range are being flipped. And plus, the inverse is also symmetrical about the y equals x line. So that's some interesting stuff right there. Now, what we'll be talking about today is finding derivatives of the inverses, both algebraically and geometrically. So finding the derivative of an inverse at an x value algebraically. Okay. All right, so find the inverse by switching x and y, then take implicit derivative of both sides, then set your inverse equation equal to the x value and solve for y, sometimes by guess and check. Evaluate dy dx at the new y point and you're all set. Okay, so we'll be using this x as our point to actually solve it. So there's actually some really cool things that you can actually do with it, okay? Okay, so we do the first step, x equals 2y squared minus 3. Then we do the derivative of both sides, which means that would be 1. And then this would be, 2y squared minus 3. In actuality, I'm sorry, it would be 4y, because when you do the derivative here, you would do the derivative and then subtract it and just work your way down, okay? All right, and then we would actually have it all set up. 1 divided by 4y equals dy slash dx. Okay, so I actually have dy dx for it. Okay, then you would have to go back to the beginning and set that equal to 3. So you would have 3 equals 2y squared minus 3. Okay, now just solving this real fast, you're probably going to find out that, let me see, what is that? 6 equals 2y squared. Okay, divide that, that should be 3 equals y squared. So therefore, the square root of 3 should be y right there, and it should be actually, sorry, the plus or minus value of 3 right there. Okay, so when you do the square root, you should work it out. Alright, and you should probably look at a graph to actually see if it is plus or minus 3 just to work with it. Okay, so if we actually plug this in, so we plug in 3, just work it that way. Okay, tune. Alright, and so this gets our actual value, so this is the square root of 3. So now that we actually have it, we can actually plug it in and be able to find dy dx. So dy dx would equal 1 divided by 4 root 3, which is also the same as 4 root 3 over, let me see, 4 root 3 over 12, which would actually turn into root 3 divided by 4, no, by 3. Okay. Alright, so that would be actual slope of the tangent line according to this actual work right here. Okay, so that's the really cool thing about just working with this inverse functions, doing it algebraically. Now geometrically, to do the derivative of the inverse graph, graph f of x and make sure it's 1-to-1. In other words, it's a true 1-to-1 function. Okay, find the derivative of f of x, then reflect the graph of f over the y equals x line to obtain the inverse. Okay, sketch the tangent line to the graph of f of -1 at the desired point, call it L. Okay, reflect the line L across the y equals x line. Notice something about it. At what point is the reflection of L tangent to the graph of f? What is the slope of the reflection of L? What is the slope of L? And what is the derivative of the inverse over x of your desired value? And that should really point out some really cool things that when you actually do this, you're actually finding out some pretty unique stuff about it, okay? All right, but that's it for finding derivatives of inverses. Just take your time and make sure you follow these rules right here. Huge follow rules, okay? All right, that's it for this. I will talk to you guys later. Bye.